You want to read chapter 16 on vineyard irrigation, which will be included. And I don't know whether there'll be additional reading assignment or not, but I don't think so at this late date. All right, last time we were talking about herbicides, and I said that there's 6 units of coursework on it, on weed control, and all we can do is hit the high points. But this handout I'm giving you covers most of the high points on chemical weed control as practiced today, except, and this is pretty important for you to mark out, in that second column, just above perennial weed control, there's one sentence that says amitrole can be used. But I told you last time that that's aminotriazole, and it is no longer permitted to be used on grapes. So mark that out. Okay, one of the recent innovations on controlling this terrible problem of morning glory has been a rather novel development of using treflan this material, which I told you is probably one of the most harmless materials to use on young vineyards, and to use a spray rig, which actually is sort of a sliding blade that goes through the vineyard, and underneath on the back side are jets to lay in, to sprinkle this treflan underneath the soil. And then, because it breaks down on exposure to light, and if you put down a solid, wet surface and then cover it, the morning glory grows right up to that thin layer and then just stops, or it goes into all sorts of contortions it can't get through. And this looks pretty promising for the vineyard avenues, that is between the rows. Then, of course, we still have the problem of controlling the morning glory in the vine row. But getting that much of the water-consuming or competition out of the way in the 6 or 8 feet of the vine middle goes a long way toward controlling the problem. Now, as I say, this requires special equipment, and it's only been in use for several years now experimentally. I told you that new materials come out so fast that it's hard to keep up with them. And one of the newest ones to come out is one called Roundup. I guess it's all one word. Which is really glyphosate, chemically. Now this material seems to be the ultimate so far for weed control. It's translocated, so it goes in that group then of translocatable materials, and it moves rather fast and quickly through the plant, so that it does a very efficient job of getting to the roots, and does a very good kill. The only point is that it will kill any plant. It is non-selective. So it will kill any plant on which you put it on the green foliage. That is, let me say it this way. Some of these materials you can put on the soil or spray on the vine, and then the material goes into the soil, and the roots can pick it up. But this material apparently is picked up very poorly by the root system, so that it's fairly safe to put it on the green foliage and not worry about drip or soil residue. Furthermore, it requires quite a high concentration to kill. And you say, well, is that good or is it bad? But remember that working in vineyards with 2,4-D, you put on an extremely small amount, 0.1%, and a little bit of drift then onto the vines can give you trouble. But if you got to give them a bath in it, then you're not going to worry about a little bit of drift. So in the next few years, as soon as this is registered for use, you will probably hear a lot about Roundup being used in vineyards. Yes?
Does that stuff break down into just carbon dioxide and water? Isn't that another one of its big factors?
I don't know. I've got a booklet here on it, but I haven't had a chance to check it that closely. But you say you're pretty sure it does. Huh? Okay. We do have this reprint up in the extension office, which covers it, and some of you may want to go by and pick it up. They have a fit when I walk in there and tell them I want 80 copies for a class. So if it's not required reading, but it might be worthwhile for you to pick it up if you're really seriously interested in planting a vineyard. Okay, we still have a few slides to look at here. Can you get one? Now, one of the things about using herbicides is that remember that most of these herbicides will kill most plants, so that you have to handle them so that you're given a differential treatment between a shallow-rooted annual plant and a deep-rooted grapevine. If you want to kill the grapevine, you can kill it too if you don't do it properly. And one of the problems is the simple little point of your irrigation procedures, which we're going to talk about a little later. And you see here they've cultivated and made a fairly deep furrow right fairly close to the vine. Now if you go and put on herbicides here, you may not get too much trouble, although it's not wise to have that furrow so close to the row. You might not have too much trouble if you furrow irrigate. But if you, let me show you a couple. This is weed kill, by the way, with herbicides. Let's see the next slide. Now here is the typical irrigation scheme, cultivation scheme in Mexico, in which they, for some reason, think that they're doing wise to put the furrows just as deep and as close to the vine as they can. And part of my whole big object down there was to tell them, you ought to plant the grapes down this ridge, and then irrigate farther out so that you can take care of the weeds. But they put the furrow just as close as they can underneath the vine, and irrigate there, and then the dry part out here then, with no weeds in it, is because the surface doesn't get wet, the subsurface does, and that's what you really want. Next slide. So if you have that type of thing, all you can do is use a Mexican weed killer. And there he is. And this is a big part of the cost of growing grapes in Mexico, is the man with the azadón or with a hoe. Chopping weeds out, all that handwork. You see, they not only put the furrows close to the row, as close as they can to the row, but then they very carefully go along and pull all the growth back up and tie it back up into the vine so that you get plenty of sun and plenty of water, and you get plenty of weeds. Okay, next slide. And that's the way they irrigate. This is the other way of irrigation, other than what you just saw. They'll put up a ridge between about every fourth row, and then uniformly flood this. Now this happened in a vineyard where the guy was just deciding to use herbicides, and he'd really sprayed this with weed killers, Carmex and Carmex, I guess in this case. And I told him, I said, you're going to kill those vines because with that much water right on top of the root system, you're going to kill the weeds and the vines. Oh no, no worry, no worry. All right, next slide. Let's see the next slide then. And that's the way they looked before I left. So he said, well, there's something wrong with these herbicides. They're a little dangerous to use. And I said, I tried to tell you that. See, the way we use these herbicides is with this high berm or ridge under the vine, and then you don't get so much leaching of the material down into the root system. But you do get enough leaching of the material to kill the shallow-rooted annual seeds or weeds that come up. So you have to use a little common sense and a little knowledge of what you're working with these various materials. They're really slick, as you saw in those slides in the last lecture, if they're used properly. But if they're not used properly, you can be in trouble. The next slide. And here's one of the problems we have in California, is that you can go in with Dalpon and perhaps lay that along the Roundup and kill off Johnson grass. But if you've got an irrigation ditch in which you're got Johnson grass on both sides, literally saturating the water with seeds every time you irrigate, when, if ever, are you going to get rid of Johnson grass? And this is a fairly, that's an extreme case, but you see it quite often in the San Joaquin Valley. That you've got to not only use it in your vineyard, but you've got to use it, obviously, along the canal or water sources that you have. One of the problems that has come up quite a bit down there is the arguments with the county, in Madera County, for example, is who's supposed to take care of the Johnson grass along the highway. The grower owns the property immediately adjacent, or the highway department, meaning the public. And that's been a controversy for over a number of years. But this happened to be in an individual grower's vineyard, and that one wasn't in Mexico. Okay, that's all slides for now. Okay, any question then on herbicides? It might be a slightly general one. Yes?
Trying to watch out for the leaching of the herbicides, definitely. What about if you sprinkle irrigate? The water's going to hit the vine or you put your herbicide?
Well, what we're talking about leaching down, we're talking about, going down. Under our California system of these soil leachable materials, we usually put it on in the late fall before any weed growth, and then it's mostly a matter of the rain washing it a little bit at a time, re-wetting a little bit at a time, so that by the time it gets down the root system, it's pretty well decomposed. That's the only answer I can give you. But some of these, for example, we talked about semazine, and we used to have one called atrazine, which is a relative of semazine, obviously. But that one leaches so well and so easily that what you're talking about works, and it moves down quickly enough so that it's pretty dangerous to use on the vines. So we no longer recommend it here in California. I saw a vineyard kill with it in Mexico because at that time there were no regulations, and I'm not sure there are now against the use of some of these materials in some of these foreign vineyards. But the whole thing on most of these chemicals is a matter of relative leaching rates. That really makes it differential on these, especially these soil sterilants. And that's why you've got to be careful, for example, when you put on Dalpon, did I mention that last time, for Johnson grass, that you don't put it on too heavy because it leaches fairly well and can give you some vineyard injury. It's also why most of these materials are not recommended on very young vineyards, when you still have most of your root system at a relatively shallow depth. So that these things have to be kept in mind, and that's what makes this Roundup material look so promising. And by the way, just as additional comment on that trephine with the blade, where you go through the vineyard, cut the top off, drop the material under, put the soil back on top. That has a few weaknesses. For one thing, if you have soils that crack when they dry after irrigation, then it's not too useful, because that morning glory will go up to the roof, and then it'll crawl along till it finds that crack and come up through it. So you've got to keep it, in that case, I guess you've got to keep a very light dust mulch on it somehow if you have soils that crack. Okay, this handout I gave you pretty well summarizes the more important facts that we've covered in the last 45 minutes of this lecture and last time. So you will be held responsible for that on the exam. Okay, now we have to start another subject, which again is irrigation. And VIT majors have to take 6 units of irrigation, and we're going to try to cover it in an hour. So yeah, you're supposed to get the main points of this in the irrigation course required for the major. But we can hit a few high points. First place, we need a few definitions and a few little general principles. Of course, the first term that you really have to know is what field capacity is. That's the most common term, field capacity. And field capacity is the amount of water that remains in a soil after it has had time for that first quick drainage, which means after most soils 24 to 48 hours after being saturated, either from rainfall or irrigation. Then the percent of soil moisture, total amount of water that's left in the soil after it comes to equilibrium, is called field capacity. So those of you who've had all these courses, this is pretty elementary material. But then the other point you need below that is PWP, or permanent wilting point. PWP, permanent wilting point. And this is the percent of water that is still in the soil when the plant wilts permanently. In other words, at the point at which you cannot irrigate it and bring it back from wilting. Or I should say, no, better strike that. You get permanent wilting point, but it's the point where that you cannot bring the plant back to normal turgor, even with a nice humid night. I used to do a lot of work with this, and where you test this with sunflower plants, and you put the pots in a box that's covered with burlap sacking, and keep that completely dripping wet to see if the plant will recover under that 100% humidity. When the soil reaches that point, you've got what we call permanent wilting point. And then the available moisture is the difference between these two. The difference is available moisture. Or available water. The difference between those 2 points. And this is, of course, pretty important for you to know when you're looking at land or talking about buying it. You've got to know something about the water holding capacity of that soil. It may vary from as little as a ½ an inch per foot of available water, or go up to as high as 3 inches of water per foot of soil that might be available. What determines water holding capacity, of course, is in major part particle size, whether you're talking about a clay soil with very fine particles, or sand, of course, and in part to the soil structure. And this in soil structure in particular is involved with how much water the plant can pull out of the soil before it gets down to permanent wilting point. In other words, you can have a clay, let's say a beat-up clay that may hold 40% water, but the structure is really completely broken down, so that you may only, your PWP may be at 20 or 25. Whereas if you have a real good structured soil, even though it's a clay, the plant may be able to pull it down to another 5% lower or something like this. But that's a rather minor point. The main thing is, say, it's a particle size. So, so with those definitions in mind, and some idea of how much moisture the soil holds, you can make some or how deep the soil is. You can make some calculations on how much water you're going to have from a winter rain, let's say, from at the beginning of the growth period. Okay, now another principle is one which there's probably been as big an argument on each side as any other thing in plant science, and that is the statement that plants grow equally well at a moisture content here, or here, or here, or here, down to the permanent wilting point. That plants grow equally well. A great number of irrigation people will argue that. Whereas others argue that, that you go from good growth up here at this type of moisture, gradually down to weaker and weaker growth as you approach the permanent wilting point. Weimar Hendrickson, Weimar, for whom Weimar Hall is named, he's retired now, lives across the street from me. But he has been the leading exponent, a leading supporter of the idea that plants grow equally well from field capacity to permanent wilting point. The man I grew up under and worked for as a technician and so forth over the years was his #1 opponent on the belief that this is what happens. So that, as I told some of you in private and some of these discussions, that wherever there's a subject that comes up in which a great number of people argue both sides of the question, both of them have to be partly right. See, Weimar has done much of his work based on the pure laboratory or blackboard thermodynamics involved. But it doesn't work that way in the field. It will work that well. Plants will grow equally well, perhaps, from field capacity down to permanent wilting point if you've got them in these greenhouse pots and a plant in which you've got every cubic inch of the soil completely filled with roots so that it draws it down uniformly. Then if you take a soil sample out of there, and as you get closer and closer, it means then that the soil sample that you take out of there is probably quite representative of the soil moisture percent right against the root, because you have so many, many roots. But suppose you're out in the field with a grapevine, and to exaggerate it, you've only got that many roots. Now, you start out at field capacity, and you start taking soil samples. And you take a sample down to here, and you still got pretty good soil moisture. You take a sample down through here, and even though it goes by that root, you're still taking a lot of soil that doesn't have any roots in it. So it still shows pretty good moisture. But what is the moisture content right next to that root? After you get down about halfway from field capacity to permanent wilting point, what's going to be the soil moisture right next to that root, which is what it's all about. And you can't measure that. So that in field experience, it still shows that the growth tapers off as you get soil closer and closer to permanent wilting point. And it's because the roots do not completely explore the whole soil mass. Now, I usually give a class about a 12-page reading assignment to expound on this in great detail, but I think this year I'll spare you that. And this is what it boils down to in short, that if you have an extremely profuse root system in a rather limited depth, and then you're measuring the soil moisture in that, then it's true that you can measure this, and that as the measurements go down, you will have a measurement fairly, when you take a soil sample and run it for moisture content, you'll have a measurement that is fairly representative of the soil moisture at the root surface, but you want here. One other point while I'm talking about this particular deal is that it also is much more important if you have salty water, because if you have high salts in the water, it takes more energy by the plant to pull the water away from the soil. It's sort of a reverse antifreeze or something like that, but I could go into it. But if you've had physical chem, you know what I'm talking about. But anyway, the point is that high amount of solutes means that it requires more energy by the plant to pull the water out of the soil. So therefore, if you have fairly salty soil or high salt content water, then you've got to irrigate higher and higher up toward, keep it closer and closer to field capacity to avoid the salt problem.
Well, don't you get a permanent wilting point at a higher percent moisture when the soil has more salt in it?
Isn't that what I just said?
I mean, it's sort of the same deal. Since there's less water, I mean, the plant can take less of the total amount of water away from the soil. So it seems to me sort of like it raises the permanent wilting.
That's what I said. Okay. I said we could go into a lecture, quite a lecture on it and discuss it, but the point is that salty soils, salty situation, you've got to have you've got to irrigate more frequently under those conditions. Okay, now another little basic principle while we're on it is that oddly enough, some people have the idea that if you, and yet if you only want to stop and think about it a minute or a few seconds, you can see that it's wrong, that if I've got a soil here and it's getting fairly dry, and I don't want to wet it to field capacity, I only want to wet it to here, that you can go out and put water on and wet this whole area. If you only put on 3 inches, if it takes 6 inches to wet it down, say this far to field capacity, maybe I'll just put on 3 inches and wet it down halfway. And there's no way to do that. But you'd be surprised how many people think that you can add water and just bring it to halfway to field capacity. Because water will not move through soil until that part where you put the water on is at field capacity. If you're putting on an irrigation, you cannot wet this area down here until this area here is at field capacity. Or you can't wet this one until this area is at field capacity, and so forth. Now you do get a few millimeters, let's say, of water movement beyond the front of the field capacity on a dry soil. But it's not of any practical importance. It's just, and it moves extremely slowly. I'm talking about wetting the soil. So there's no such thing as bringing a vineyard soil or any soil up to halfway field capacity. The only way you could do that would be to do it in a bucket in the laboratory, put the water on, and then mix it up. That's about the only way you could get a halfway field capacity. Okay, now obviously, I'm just trying to hit some of the high points of irrigation. Now obviously in irrigation, if you're irrigating well, I could have used this one right here. Obviously, again, if you're irrigating a sandy soil, let's put a furrow in here. If a sandy soil, the water goes down more or less like this. But if you're irrigating a heavier soil, it'll go out wider and wider like this before it goes down. Or in a real heavy soil, it might really wet a great area in width as it goes down. So in sandy soils, you've got to keep in mind that you've either got to flood the whole thing or have a lot of furrows in order to wet the soil uniformly in the rooting zone. And you've got, of course, if you're going to irrigate vineyards, you've got to irrigate them down through at least the maximum root zone. And in grapes, we can get roots that go down on some of these heavy soils, may only go down 2 or 3 feet. But in sandy soils of the San Joaquin, I told you before that I've found roots 30 feet deep. They're as big around as this chalk. I've seen them. But of course, most of the roots in those sandy soils are down around 2 to 4 feet. So you've got to be sure to irrigate that deep anyway. Now we were talking about salty water and irrigating more frequently under those conditions. Remember what I said in 116a, I think, that if you have bad water, salty water, you not only have to irrigate more frequently, but you have to apply more water. The worse the water is, the more you have to put on, which seems contradictory, but if you have bad water, you've got to put on enough water each time under most conditions to wash out the salt that was left from the last irrigation, which means that you have to do a leaching job as frequently as possible if you have bad water. So you irrigate more frequently because of this water tension thing, and use more water to do so. But if you're, and again, that may seem rather obvious, but a couple of growers came to me at one grape day and said that our water is so bad we put on just the absolute minimum that we can, just barely enough to wet it down to the root system and quit, because we want to put on the minimum amount of salt. Well, that was just the opposite, of course, what you should do. But under their conditions, in which they were on hard pan at about 3 feet, if they put on lots, and they didn't have very good leaching or good drainage, you can only do this, of course, with grow grapes with salted water if you have good drainage. So under those conditions, they were rather stuck, because if they put on a lot of water each time, they were liable to end up growing the vines in that underground bathtub I was telling you about. And in the summertime, you can't do that. So I told them, okay, the answer in that case is to put on your minimum amount of water during the growing season. But then as soon as the growing season is over, pull the plug and really soak it, and soak it and soak it during the dormant season to leach out those accumulated salts. And doing so, they've improved their vineyard situation somewhat. Okay, now that sort of as a once-over lightly on the basic ideas of irrigation. We want to talk now about the grapevine itself and when it needs water and so on. Obviously, the grapevine needs a lot of water in the early spring when it has that grand period of growth. So you've got to give it, you've got to be very sure that the vine does not have any suggestion of a need for water, certainly up to bloom time. So that you've got to have plenty of water up to that time. And under practically all other conditions, you've got to have a good water supply as long as the berries are increasing rapidly in size, that is, in the month after bloom time. And I said in practically all conditions, because one of the things that we have found out in the work with grapes is that if you let the vine suffer for water during in that month after bloom, when the berries are growing so rapidly, and then you come back from your fishing trip and rush out and put on water, you will not cause the berries to catch up in size with those which have had a normal supply of water. If they're stunted, if the berry growth is stunted in that month after bloom, when they're increasing in relative volume so greatly, you cannot correct it if you just keep them completely well watered from then on. Okay, what does that bring to mind then? It brings to mind one little situation. You can use this fact with some of these varieties in which you get bunch rot. If you're willing to take a little sacrifice in crop, let them run a little bit low on water in that month after bloom, and make all the berries smaller and looser clusters and probably a little better quality fruit. But of course, you're going to pay for it in a reduction in crop. And also, you're walking on thin ice, because you might decide you're going to let them get a little dry, and you might get a whole lot too dry. So it's a careful technique with varieties like Grenache in particular that suffers from bunch rot to reduce berry size. But it's a tricky deal to handle. So until about a month or so after bloom, you want to make sure that there's no possible shortage of water. Well, how do you know when you've got shortage of water? You hear about all sorts of equipment and so forth that's being used for determining soil moisture. One is the Kinsey Ometer, and here's a picture of a Kinsey Ometer. They cost about $25 a piece, and what they've got is a very fine porcelain tip here, which is permeable to water, of course, and then a column of water, and connected to a vacuum gauge, and then you stop it and fill this up and stopper it, and then as the soil dries out, it pulls the water out through this porcelain or glazed thing here, not glazed, but porcelain tip. And as it pulls water out of that tip, it pulls a vacuum, of course, on the gauge, and you can read the vacuum gauge and determine something about the soil moisture. Then when you irrigate, the water goes back the other way because it's under vacuum and fills up and releases the pressure, and your reading goes down. That basically is what a tensiometer is. It's measuring the tension. Yes?
None of those can read more than 1 atmosphere.
No, I'll get to that. But this instrument costs about $25. You've got to have a number of them at different depths and different locations to give you a good average reading. But perhaps their biggest disadvantage, other than cost and the time it takes to read them and take care of them, is that they theoretically should read up to a full atmosphere of vacuum. But they don't, because the time, in other words, they should read up to 100 if the full atmosphere is broken up to read up to 100. But when you get up around about a reading of 60 or 70, you get air leaks down here and get air sucked into the line, and that, of course, ruins your vacuum. So that they're only really useful up to about, let's say, an average of 70 under most conditions. And most grapevines don't need to be irrigated till you get up around 60 or 70. So if you're going to have to, again, walk the tightrope of playing with these tensiometers right down to the point where you begin to lose efficiency or lose effectiveness or accuracy, then I really don't see that they're so wonderful. And also it makes a great big deal of difference whether this tensiometer tube, I'm tied into this thing. Let's say this thing now is a tensiometer tube. It makes a whole lot of difference whether the end of that thing happens to come right close to a very active root zone, in which it'll dry out, in which the tension will build up very quickly, or whether it's sitting over here where there's no roots at all. And that's why you get quite a variable reading among these things, even when they're working properly. So you have to sort of average them out. But anyway, you'll hear these pushed quite strongly and oddly enough by several farm advisors who recommend them very strongly. Well, you don't really need that at all. Another point, let's have the lights, Let's have that slide marked with me. See, here's the limit of the tensiometer reading. The limit of the tensiometer range, but here's the available moisture depletion, the percent depletion. So that the tensiometer here is not any good on this clay soil, and you still got 75% of your moisture left. And it's better and better on these fine sandy soils and so on, where the water movement is a little easier and more free. But even under the fine sand, loamy sand, you still got nearly a quarter of your available water left when the tensiometer goes kaput. And that's assuming that it works up to, this graph doesn't take it to 100, it takes it to about 90. But in my own actual experience, I know it breaks at about 80. So you can see that the tensiometer really has its limitations. Okay, the way to find out whether or not you need to irrigate, let's go into that. Next slide. You can tell with a little bit of experience just by looking at the vineyard whether or not it needs water. This vineyard needs water. You see there's no new growth. It's all green. It's turned a sort of a dull, dark green here, but there's no new shoot growth. And that vineyard should have been watered a week before. Next slide. See, boy, that is a dark one. Here's what you want to have in a vineyard is a lot of this type of growth. These long shoots sticking up like this. See, the tendrils elongate faster than the leaves develop. So when you see these light yellow-green shoots, with quite a few of them, or not quite a few, as long as the vineyard shows maybe a half a dozen or 8 or 10 of these per vine, after that month that we were talking about, after that month, a month after bloom, then you don't need water. I think the next slide shows it a little better. This is a type of growth that indicates that your vineyard has plenty of water. And if you've got that type of indicator, why do you need tensiometers or any of this other type of equipment that's going to cost you a lot of money and a lot of time to take care of it? But as long as the vine shows this light yellow growth with those long tips like that and the profusion of those tendrils on top of the vine, it's got plenty of water. And it should be like that, as I say, until about a month after bloom. Then you can begin to taper it off, and down to the point where maybe 6 weeks after bloom, you may only have 3 or 4 of these per vine. But then, okay, is there another slide? No, okay, that's enough right there. Just a moment, and we'll go on with it. Now, we want, after about midsummer, and here in California, in most of our wine vineyards in particular, many of the growers on fairly heavy soil don't irrigate after the 1st of August or the middle of July in some cases. Around Modesto, some of those vineyards are not irrigated again after a good irrigation in the middle of July. The wine grapes, now I'm emphasizing wine grapes. And raisin grapes are not irrigated down in Fresno area and so forth on those deep sandy soils after the 1st of August. Because why? I've told you this lots of times in different ways. Now you want to slow the growth down so that, that the energy that's being produced by those leaves is going to go into maturing the fruit rather than into producing more excess growth that you'll just have to cut off next winter. And it'll also harden up give you maturity of wood. But table grapes is a different matter, of course, because there you've got to maintain the irrigation up to within about a week or 10 days or so of harvest time in order to get keep the fruit turgid and to get good bearing fruit. As table fruit or any of these fruits begin to suffer a little bit from water, they take on a sort of a dull, tired look. And that, you don't mind that on the wine grapes, but if you're going to sell your table grapes, you've got to keep them turgid and shiny and crisp. And in order to do this, you've got to keep water on them right up to close to picking time. Now, a lot of growers will knock the water off 10 days or so, 2 weeks maybe before picking of table grapes, because it will give you just a little bit of an edge on your neighbor if your grapes can be bought right up to that picking time with just a little bit of water deficiency, because first you've slowed down the growth some, so you're getting a little bit more sugar into the grape, and furthermore you can get just a little bit of loss of turgidity and increase your sugar reading slightly by a concentration effect. But again, like this business of the Grenache after bloom time, it's a tricky business to bring them right up to that. And then some growers pick over a period of several weeks. They go in and pick once, and then to skim the cream, and then go back later and pick the later ripening material. And under these conditions, they sometimes have to irrigate in between the pickings. And some grapes are pretty tricky on this too. Cardinal and Ribere are liable to crack on you if you let them dry a little bit too much and then slap the water to them to swell them quickly. The way cherries crack in the rain and dates crack at the tip and so on. When they get a little bit dry and then you throw the water on them real quick, you're liable to get some cracking of berries. And the best way, of course, of handling this is to put on a light irrigation and alternate middles in between those pickings. A light irrigation and alternate middles will take care of it. And then also, after these early grapes are harvested, these table grapes are harvested, it's a good idea then, from then on, to just irrigate and alternate middles and stretch your irrigations farther and farther apart, so that your last irrigations, if you do have in a real hot area, may be a month apart instead of 2 weeks as it were in the early summer, and will be alternate middles so that you taper them off. You want to bring them into that fall time, approaching cold weather period slowly, so that they're maturing the wood, and yet you don't want to leave them completely dry so that the leaves fall off. And with raisin grapes, they're the ones that really take a beating, because the Thompson seedless, they quit irrigating the 1st of August so they can dry out that surface soil, so they can sugar up the grapes, as they say. And then they cut the grapes and put them on the ground and leave them there for a month, starting the 1st of September. So they have gone through the month of August and September, the 2 hottest months in the valley, 2 full months without any water. Then when you pick up the raisins, the 1st of October, or the last week of September, the question is, do I irrigate now or don't I? And we've been carrying on an experiment for about 6 or 8 years at Kearney, trying to find out if it makes any difference. And in the particular location at Kearney, it doesn't seem to make any difference whether we irrigate after harvest or not. And we've been trying to see if we could let them go through that 2 months of dry period and then slap water on them and see if this throws them into a flush of growth, which would make them more susceptible to winter kill and winter injury. But so far, theoretically it should, but in actual practice it hasn't in that particular location. But regardless of that, in all cases, with all vines and all vineyards, once you get the harvest off, get the grapes off, and once you get cold weather enough to be pretty sure that you're not going to get any danger whatsoever of bud break from a sudden irrigation, then it's good to go in and irrigate the vineyard thoroughly for the winter. And just one good irrigation to completely wet the soil after the first dormancy is assured is a good practice. You don't want the vines to stand there in air-dry soil all winter long. But it doesn't mean you got to go out there every month during the winter and irrigate, because once you wet the soil down and there's no appreciable leaf surface left, what's going to dry it out? Nothing. So you just irrigate them once thoroughly and then leave them. And I think that covers most of the basic principles. Of course, one other thing we need to add here, of course, is time and frequency of irrigation. And there's 3 main factors, which ought to be pretty obvious. It depends on how hot the area is you're growing the grapes in. The heat summation. Obviously, you're going to need more water in a region 5 than you are in a region 1. And then the frequency of irrigation will depend in part on your soil reservoir, how much water it'll hold. And that depends on the texture and the depth of the soil. The texture for this field capacity, how much water you can hold there. You see, in some cases, you can go from something like 40 down to 20, which gives you a range here of 20% for available moisture. But in some sandy soils, you may go from 15 down to 5 or so, and have about half as much available water per foot of soil. Here at Davis, we have about 1 inch of available water per foot of soil out there in our vineyard after an irrigation. Okay. Well, time's up, I guess. And then we want to talk about girdling. And this is a time when you have to irrigate, because when you go in and girdle for table fruit, you really interrupt the water conducting tissue greatly. So you've got to get the water on immediately after girdling in order to reduce the damage from that. But we'll discuss that when we discuss girdling. Okay, that's all for today then.